Unit 4. We're doing part 2 of 4.3. We're still on probability. And we're still going to mostly look at words. But let me put an example on the side here that we're going to refer to. So I'm going to call these events. Event A is get a prime number. So event A consists of 1, 2, 3, and 5. Event B is get a 4, and event C is get a 6. So can you see that event A and B and C, if we throw them all together, we've got all the possibilities. Right, now we're going to look at some. Let's start off with and saying the probability of event B. The probability of getting a 4. Remember your rule. How many 4s are there on a die? 1. How many sides are there on a die? 6. So the probability of event B is 1 out of 6. Can you see that would also be the probability of event C? Getting a 6 is still 1 out of 6 because there's 1 6 on the die and there are 6 sides. Right, here's a word, complement with an E, not an I. That would be, it's like okay, and now I'm getting myself confused here. Let's make a new example. If event D is get an even number. Then the complement of D you write as D with a little dash like that, and you read it as complement of D is get an odd number. Now that still doesn't exactly explain what I want to say. The two events, an event and its complement, must make up all possibilities. So D and D prime together make all possibilities. In other words, make up my sample space. D plus D prime must equal your sample space. That's what we mean by complements. Now, the certainty, if the probability of an event, let's just give it a completely new number, event, call it E, is 1, then it is certain. Then it is actually, E is then really your sample space. In other words, the probability of getting a 1 or a 2 or a 3 or a 4 or a 5 or a 6 is 1 because you are going to get one of those. It is certain. So, that means the probability of an event plus the probability of its complement will always equal 1 because they make up the full sample space. So there's one important word. Now another one, mutually And be careful, one gets confused with all these words because they're kind of similar but not the same. Mutually exclusive events cannot occur at the same time. So in our example, complements are definitely mutually exclusive because they can't be the same because the one is like the opposite of the other one. But A and B are mutually exclusive. A and B are mutually exclusive because you can't get a value from A and a value from B at the same time. A and C are mutually exclusive. B and C are mutually exclusive. D and its complement are mutually exclusive. So it's impossible to say, let's toss a die and I want to get a 4 and a 6. If you only toss the die once, you're only going to get one value. So you can't get a 4 and a 6. They are mutually exclusive events. Right. Let's look at another word. So be careful. Independent events. You get the complement, you get the mutually exclusive, you get the independent. The independent events, I'm just going to say, have no effect on each other, and then I'm going to explain what I mean by that. Independent events, I mean, if I do one experiment and thereafter I do another experiment, the second one, its outcome should not depend on what happened with the first one. So, for example, toss a die, then flip a coin. What you get from flipping a coin has no effect or no result from tossing a die. Whatever I get on the die is not going to tell me what's going to happen when I flip a coin. Even if I said my two events are flip 2 coins. If I flip a coin, I can get head or tails. If I flip the second coin, I can still get head or tails. So the second action is not dependent on the first action. Now, please notice the difference between mutually exclusive and independent. With independent, we're talking about doing one thing and then doing another thing. Mutually exclusive is where I'm saying, if I do one thing, can I get an answer that comes from both the others? So mutually exclusive would not be, let's say, A and D are not mutually exclusive. Because I could get, remember D was get an even number. But there are even numbers in A. 2 is an even number. So if I got a 2, it did come from both A and D. But it was still just when I did one action, could I get a result coming from 2 of my events that I have decided on. Whereas independent events are, if I do something and then I do another thing, the next one doesn't depend on what happened the first one. So when would it not be independent? Let's think. if I have, let's say, a bag with colored discs in it. We will use this example again later. So for instance, there are 3 blue, 2 green, 5 red discs in there. Now, if I draw a disc, I look at its color and I don't return it to the bag. Then I draw another disc. Okay, let's just see this again. Imagine you've got this bag and there are all these discs. You can't see inside the bag. You put your hand in, you draw a disc. You note its color. It's either blue or green or red. But you don't put that disc back into the bag. What happens now with your second draw? You've only got 9 discs left to choose from. So your sample space only consists of 9. So here, your sample space had 10. Here, your sample space now only have 9. So the denominator is going to change. And then furthermore, if for instance your first one was a blue, then in the second case there are only 2 blues left. So your probability of getting a blue again is going to be different. It's influenced by what happened with your first draw. So those are independent events. Right, this lesson, very important. Make very sure you understand what we mean with these words.